Hello everyone, I am Pooja Shishikar and today I will be presenting on issue in design of code generator, which is final phase of compiler. So before seeing the design issue in code generator, let's understand about code generator. Code generator is a final phase of compiler which take input as a intermediate representation of source program and produce output and equivalent target program. So let's see position of code generator. So here is the position of code generator which take input as intermediate code and generate target program. So intermediate code is produced by a front end which take input as a source program and convert it into intermediate code. So intermediate code is the output of the front end, and this output is gives input as a code generator and it produce a target program. So front end compiler consists lexical analyzer, syntax analyzer, semantic analyzer and intermediate code. So these all phases are connected to the symbol table, and symbol table is mainly known as the data structure of compiler. It helps in storing the identifier with their name and type. So symbol table is connected to the all phases of compiler. Code generator can be used with or without optimization phase. So let's see the design issue of code generator. So first input to code generator, second target program, third memory management, fourth instruction selection, fifth register allocation and sixth evaluation order. So first design issue of code generator is input to code generator. So input to code generator is an intermediate representation of source program which is produced by a front end. So means as a input it take intermediate code. How the intermediate code is look. So it look like a linear representation, just like postfix expression. So here you can see the intermediate representation can be linear representation, 3 address code, virtual machine, graphical representation means syntax tree and DAG. DAG means direct acyclic graph, and you need to assume the type checking is done. So means input is free of error. Means in input to code generator issue, you first give input as an intermediate code which is in form of linear representation. Why it is form of linear representation? Because before performing the type checking, the code is free of error. The next design issue of code generator is a target program. So here target program is nothing but output. Output may be in any form like absolute machine language, relocatable machine language or assembly language. So absolute machine language means it is a executable code which is stored in a static memory, and relocatable machine language means it is a object file which is needed to linker and loader. Linker link the object code of serial program into a single program and it gives output as a object code, and object code is loaded by loader. And assembly language is nothing but debugging. And next design issue of code generator, that is third, is memory management. So memory management, the front end and code generator map variable name to memory addresses. The label in 3 address code are converted to instruction address. Means mapping the name in the source program to address of data object is done by the front end and code generator. Source program first enter in a front end and then in back end compiler in a compilation process. So everything is done by a front end and code generator. A name in 3 address statement refers to a symbol table entry for the name. So as I said, symbol table is connected to the all phases. So it will be store the data of identifier with their type and name. So it store the all information related to the variable. Okay, so in a backend phase, if it this compiler is performing any operation and he need information of any variable, so it just look in a symbol table, so it find the relative address of that variable from a symbol table and perform the operation. And then fourth design issue of code instruction is, next design issue of code generator is instruction selection. So as I said, code generator take input as an intermediate code and it converted into the target machine instruction set. So the instruction of target machine should be complete and uniform. Then means the one representation can have many way to convert it, so it is a responsible of code generator to choose appropriate instruction. So code generator select itself proper instruction, and the quality of generated code is determined by its speed and size. The formal statement can be translated into the latter statement as shown. So this is less understand by example. So here expression is x is equal to y plus z, and we are converting this is into the assembly language. Okay, first we are storing y in R0 register. So we are moving y in R0 register. They are performing the addition of R0 and Z. So R0 is nothing but y. So we are performing the addition of y and Z and storing result in a R0. So at the end, the result we are store in a x variable. Next design issue of code generator is a register allocation. Allocation. So instruction involves register operand. Operands are faster and shorter than those involving in operand in a memory. So some operand are stored in a register and some are directly stored in a memory, but the operand which is stored in a register, it is a more faster than operand in a memory. So means if we want to perform a more operation, but here have a limited number of register, so this is the problem. So here with help of limited number of register we need to perform the operation, so then we get a efficient target code. So the use of register is divided into two sub problem: register allocation and second is register assignment. Register allocation means, suppose there are two variable a and b and we are allocating a for R0 register and for b we are allocating R1 register. So this is nothing but register allocation, means the set of variable that will reside in register. And register assignment means R0 register we are assigning to A and R1 register we are assigning to the B variable. So register assignment means specific register that variable will reside in is picked up. And next design issue of code generator is evaluation order. The order in which computation are performed are affect the efficiency of target code. Some computation order required fewer register to hold intermediate result than other. So let's understand by example. So here the expression is a plus b minus in bracket c plus d into e. So this expression is converted into the 3 address code. So it is a intermediate representation. So for this we are and this is we are converting in assembly language. But here first we are performing the addition of a and b, then addition of c and d, then multiplication, and at the end we are taking that all the result and performing the subtraction. And if we execute this assembly language, it not gives a proper result, because as a bottomless rule, first we are performing the bracket expression, so then we go multiplication and then addition and subtraction. So for that we have to follow some order. So here we convert it into the correct intermediate code. So here first we are performing the addition of c and d, means first we executing the bracket expression, then we are performing multiplication, then addition. So after this all result taking, we are performing subtraction and storing the result in T4. And this is a assembly language code of this 3 address representation. Okay, the conclusion is code generation must balance correctness and efficiency. Careful handling of memory, register and instruction choose is critical. So final target code should be optimized for execution. Thank you.